Hi there, my name is Prasad and welcome to my today's video. I hope you guys are doing well. So let us start discussing today's topic. So if you have seen my earlier video on adjacency list, I briefly spoke about a variant of adjacency list. Basically, we discussed these operations and we compared the performance of adjacency list and adjacency matrix, and we saw that adjacency list does better in terms of performance, time complexity for this operation and for this operation, but it lags somewhat in this operation. So if I need to check if the edge exists between two vertices or two nodes, then and if we have adjacency list, then we have to scan the corresponding adjacency list of that particular index. So the time complexity will be the order of degree of that particular vertex. But if we see adjacency matrix, then if you have both the columns, then you can directly take the row and column and go to that cell and check if it is 1 or 0. If it is 1, the edge exists between those two vertices. If edge doesn't exist, then there will be 0 stored in that particular cell. But to overcome this flaw or this drawback in adjacency list, there is another data structure which we can use that is called as adjacency map. So it is similar to adjacency list, but there is a slight difference. So here, as we have seen, we store the adjacent vertices of this particular vertex in the list, right? We can see that it is another. We can say that it is another array, or we can say it is a list or array list of the neighboring vertices. But instead of storing them in a list, if we store them in a map, as I have shown here, it might not be clear, but here if you see, I'm storing the vertices in key value format. So I will store key as vertex as a key, and I can store any dummy value as a value, or if it is a weighted graph, then I can store weight of that particular edge as a value. So instead of using this adjacency list, I can start using a map to store all the adjacent vertices in key value format. So if we use this, what will be the time complexity of this operation? So it is obvious. Hashmap retrieving the data from hashmap takes constant time. So I can directly come here and get that particular matrix, that particular node from the map in constant time or O of 1 time. So if we use this data structure, then we can do better when we talk about this operation. And another advantage, probably I might have talked about it in the last video, is that if we don't have convenient integers as the vertices, here we have 0, 1, 2, 3, 4, 5, 6, right? These are the vertices. But what if we have been given the name of the city? So you cannot use an array or array list for that purpose. So there also adjacency map does better, or it is more easier and convenient to store it in adjacency map. So here you can store this key will be the city name, and then all the adjacencies you will use it. It will be basically a map of map. So in terms of Java, I can say it as map of string and another map of string comma boolean. So here I'm considering boolean because I'm talking about unweighted graph. There are no weights assigned to the edges. But if it is the graph with weighted edges, then instead of boolean we can store an integer. So so that will be the only difference. So if I use this kind of structure, then it is very useful when we have the name of the vertices which are not convenient integers. So yeah, other than that, it performs the performance is if we talk about this operation, finding the adjacent nodes and finding all the edges, it is the performance or the time complexity of adjacency map is equivalent to adjacency list. There is no difference in the performance because it has to scan whole map to find all the edges. So the time complexity will be similar. So that is all I have in this video. In the next video, I will talk about Eulerian cycle and Eulerian path, and then I will start in the subsequent videos. I will start talking about graph traversal techniques. I will start from DFS and then DFS and other techniques. So until then, bye bye.